Hello. So we are. This is a new chapter, and in this chapter we're going to look at straight lines. So again, we should be very familiar from GCSE. Obviously, a straight line looks something like that, right? We've looked at this even in the early chapters, but we're going to look in a bit more detail, right, in this chapter with straight lines. Now, straight lines then. So, um, first of all straight lines have, if you plot it on an axis, right, x, y, a straight line will have something like this. And two key parts of a line is that firstly it has a y-intercept, and that is the point. If I can write it, there we are. And that is the point where it crosses the y-axis. Okay. It has a point where it crosses the x-axis as well, but that's not as important. We'll go over that in a second. And it also has something called the gradient. Now, the gradient of a line, or a gradient of any curve in general, is a measure of how steep the curve is, or how much it's going up by. So, let's have a look then. So, we firstly have, let's say, this line that's going up here. Then I have this line that goes down there. Then I have this line, and then I have this line. So I have four different lines, right? I'm not drawing it on the grid. Just literally just a straight line, right? Now, this is in order of decreasing gradient. So as I go along these lines, the gradient decreases, and that is because again the gradient is a measure of how steep the line is. If you imagine sort of the line as let's say someone climbing up a mountain or a hill, right? Now, how hard would you have to work to basically walk up that hill, walk up that line? That's a measure of the steepness, right? So the steeper, or how high up the line goes up, is a higher gradient. Okay, so this is the steepest line, so it's going to have a higher gradient than the other lines. Then this line then is going to have it's a less steep, but it's still going up. So it's gonna so the gradient's gonna be lower than this. Then what about this line here? But this line's particularly, it's just a completely flat line. It's a horizontal line. Well, the gradient here is 0 in this case. So I'm going to say grad equals 0. Here, the gradients here are positive, but we'll go into that in a second. But this line is a 0 gradient, that we call it, because it's not going up at all. It's not going down here, but it's just completely flat, right? So it's equivalent to like walking on the street or something like that, right? It's not a hilly sort of terrain. It's just a completely flat line. So it has no gradient because it's not going up. Okay, there's no steepness. Okay, then this last line here, well, it's actually going downwards, right? It's going downwards. The other two were going up, right? Up here and up here, these two lines, right? Now this line is going downwards. So what that means is it's a negative gradient. Okay, and these two were positive. However, this one would be higher than this one, gradient wise, because it's the first line here is more steeper than the second one. Okay. But they're both positive because they're both going up, okay, at the end of the day. This one's going down, so it's negative, and it's like a slide, I guess. If I draw another sort of interesting diagram, it's like a slide, so it's going downwards, so you're not really climbing up at all. In anything, it's helping you go down. So it's far less steep, because it's actually going downwards, so it's negative. And then if you had a line like this, that's even more, that's even like going even more downwards, then it's more negative, okay, than this line there. But yeah, so that's just an example of the gradient, right? It's just a measure how steep the line is, and then if you imagine like trying to walk up the line, how hard it would be, right? Okay, cool. Okay, well that's just a general idea. So how would we actually calculate the gradient? Well, again, obviously for GCSE, you'd remember changing y and changing x. But let's start to actually see it properly numerically. Okay, so a line basically is between 2 points, right? If we call this first point x1, y1, so obviously every point has a coordinate xy, okay? So we can call this first point x1, y1, and then this second point x2, y2, okay? Now the gradient, or how steep the line is that goes between those 2 points, we say it is the change in y, so the difference of the two y coordinates, so y2 minus y1. So that's going to correspond to this vertical distance there over the change in the x coordinates, so the x values, so x2 minus x1. That's going to correspond to that horizontal distance there. Okay, so the gradient is to the difference in the y values over the difference in the x values, or what you might very commonly known as change in y, which is the change in the y values over change in x. Okay. Now the key thing to mention here is that you have to keep the order of the coordinates the same. So if you're taking away the second y coordinate by the first one, you can't then do x1 take away x2. No, it has to be the same coordinate, the same order. So then if you do the second y coordinate first, then you must also do the second x coordinate at the bottom there first as well. But we'll see that in a minute. But yeah, so we can calculate it as essentially the difference of the coordinates, right? The change in y, change in x. Okay, so that gives us a numerical way of finding and working out what the gradient is of a line. So that's the gradient, and then the y-intercept we discussed. So in general, when we have these two details, so we can work out the gradient and the point y, the y-intercept. As again, the y-intercept would be simply where it crosses the y-axis, like there. Once we've got those two ingredients, we can then formulate the equation of the line. And what we say the equation of a line is, like with a quadratic, we say it's ax squared plus bx plus c, right? That's sort of the standard form of quadratic. We looked at that earlier in the course. The standard form of a straight line is y is mx plus c, okay? And so m, which is conveniently called m here to represent the gradient, m is the gradient. Again, we can work out by given 2 points, we can calculate the gradient by doing the change in y, change in x. And c is the y-intercept. So we could look on, say, a graph where it crosses the y-axis, so we can work it out that way. Once we worked out those two ingredients, we then got this form of a line here, okay? There we are. So we will be using that in this section and indeed later on throughout the course. But yeah, it might seem basic, I guess, a recap what you've already known, but it's really good to go over it, right? Because it is a key topic we'll be using later on. Okay, and vice versa, if you're then given the equation of a line, you can then work backwards and work out what the gradient, the y-intercept would be by just looking at the equation. Or there might be a case where we might need to use some algebra to substitute a point in. But we'll see some questions as we go along. Okay, cool. So that's y is mx plus c. That's what we're going to be using in this chapter. Cool. So let's have a look at this example then, this first one. First of all, it's asking us to work out the gradient of the line joining minus 2, 7 and 4, 5. Okay, so gradient then is just going to be your change in y, change in x. So again, changing y, so that's the difference in the y coordinates. Now I tend to do the second point first. I guess, for me, I know it's more like logical and clear in my mind, but it's up to you. But we need to pick one coordinate. I'm going to pick the 4, 5, and that'll be your the coordinate you're going to start with. So again, changing y is first with the y coordinate 5. Then we're going to take away by the other y coordinate, the other point 7. Okay, so it's changing y. Okay, the difference in the y values. Then we're going to do the same for the x. So firstly, because we started with 5 from this coordinate, we must then keep the same order and do 4, okay? So the x value of the second point, take away -2, okay? Now, we can actually tidy this up. We can calculate the top and the bottom bit. So 5 take away 7 is -2. Then 4 take away 2. Well, hopefully you notice it's a double negative, which will turn to a positive. So 4 add 2 will be 6. So this is now the fraction -2/6, which should simplify to -1/3. Okay, because we cancel down by 2. And there we are. So that's our gradient then. Cool. Okay, example 2. The line joining 2 minus 5 to 4a has gradient -1. Work out the value of a. So again, you can kind of work backwards or use some algebra in this sort of problem. So the gradient's -1. Let's work out what the gradient would be. Okay, because we've got 2 points. What would that look like? Okay, so firstly, it's changing y, changing x. Now, of course, when you get more proficient with this, you don't have to write this whole thing down. You can just jump right into calculating it. But then the change in y, well, again, I'm going to take this coordinate first. So it's going to be the y value a here. Take away the other y value of the other point, take away -5. Then we're going to do the same for the x value. So we're going to start with 4 now, because that's the point we're starting with. So 4, take away the other x coordinate of -2. Then that's going to then we can simplify that. So it's going to be a minus -5 would be a plus. Again, double 2 negatives, so it'll be a plus 5 over 4 minus 2, it should be 2. Okay, we can't do anything more with that. Okay, but we're told the gradient is -1, so this whole thing m has to equal -1. So that's what I get, and hopefully you recognise it's a linear equation, right? We can solve those. We looked at that earlier on in the course, but also I hopefully remember it from GCSE. How do we solve it then to solve for a? Well, then you first want to get rid of the fraction, so we're going to times both sides by 2 to therefore get a plus 5 is -2. Then we're going to subtract 5 to both sides, so a simply -2 minus 5 be -7. And there we are. So there we are, and I would start to get comfortable with this idea at A level, if you because it's a bit it's fairly new into this into AS, this topic, so you still might be a bit new to the course, but at A level you will be tending to use algebra with problems like this rather than a straightforward sort of question like this usually, but it's not too bad. But it's a good idea to do these questions, start to get to practice and get the rhythm of the algebraic way of thinking. Anyway, example 3. So we are told to write down the gradient, the y-intercept of these lines. So firstly, y is -3x plus 2. Now again, recall what I talked about. Equation of a line should be in y is mx plus c form. We also call that slope-intercept form. Now we will be looking at another version of a straight line next chapter, I think, sub-chapter, the next time anyway. We can write this, a straight line in another way, but this is I think the superior way. But anyway, this is y is mx plus c. If you rearrange a straight line in this form, you can quickly and clearly read off what the gradient and the y-intercept would be. Well, that's going to be the gradient, and that's going to be the y-intercept. Okay. Well, conveniently, this equation is already in that form, right? So I can then read off that the gradient is -3, and the y-intercept is going to be +2. Okay, cool. Then part B, we have 4x minus 3y is plus 5 equals 0. Well, it's not in this form, right? Y is equal to mx plus c. Well, that's telling me I need to rearrange this to get y on its own. So that's what I'm going to do. So firstly, I'm going to I'm going to move the minus 3y to the other side. So 4x plus 5 is equal to plus 3y if I add 3y to both sides. But then that's 3y is equal to this. So then I need to divide by 3 to just get y. Therefore, y is going to be 4x over 3, if I divide everything by 3, plus 5 over 3. Okay. Now I can make this a little bit clearer, because then I can say it's 4/3 of x, right? Plus 5 over 3. And hopefully now it's very clear what the gradient of the y-intercept will be by comparing it with mx plus c. So that's going to be your gradient, because that's in front of the x. So gradient is 4/3. And the y-intercept would be 5 over 3. There we are. Cool. I should also say that the y-intercept is actually a point. So we need to get the y-intercept as coordinates. So firstly, part A of 2, that's going to be 0, 2. Remember, because the x is 0 at the y-intercept. So then, and for here, part B, the y-intercept as a coordinate is going to be 0, 5 over 3. Okay. Remember the fact if that's for y-intercept, then it wants a coordinate, because that is what the y-intercept is. Okay, it's a point. Okay. So there we are. Example 4 then, write these lines in this form here. Okay, so they want you to rearrange these lines into that form. So let's have a look. So A, firstly, y is 4x plus 3. Okay, well, first of all, notice everything has to be on one side equal to 0. So I need to move all of this on the right side onto the other side. Okay, so therefore minus 4x minus 3 plus y equals 0. Well, actually now it's in this form, right? Everything is equal to 0. So therefore, well, I can rearrange it to exactly this form to then get minus 4x, and then the y, bring the y into the middle instead. Minus 3 equals 0. There we are. And hopefully then you can read off that a is going to be minus 4. Here, the coefficients, right? B, the coefficient of y will be just 1. And then C, the number at the end, is going to be minus 3. Okay. Cool. Then part B, y is equal to minus a half x plus 5. And then again, we need to firstly group everything onto one side. So let's move this right side onto the left. So then we're going to get, if we add half x, we're going to get half x minus 5 plus y equals 0. Cool. Okay. But then this is in this form here, right? Well, if I put the y in the middle again, it's very clear then that half x plus y minus 5 equals 0, and that is in the form the question wants it in. Okay. Now you could tidy this up by scaling the equation, right? Times both sides by 2 to get rid of the fraction, because we don't like fractions ideally, right? So then we have x plus 2y. If we double every term, minus 10 equals 0. And therefore then we could say a is 1, b is 2, and c is minus 10 by comparing the terms, the coefficients, right? Cool. Okay, this example 5 then. The line y is equal to 4x minus 8 meets the x-axis at the point P. Work out the coordinates of P. Now, I think it is useful to do a little sketch. So it meets the x-axis. So what's that going to look like? So this line, so positive gradient of 4 and a y-intercept of minus 8, it's going to look like that, right? Now it's saying it meets the x-axis at the point P. Well, if I label this x and y, right, with this little sketch of a graph, well, meeting the x-axis is going to be this point there, the x-intercept, and that's going to be P, okay? So we need to find what P is. So the coordinates of P, well, what is special at P? It's kind of like a root, isn't it? We discussed roots at length in the previous chapters. The route passing through the x-axis means the y is going to equal 0, okay? So P is going to look like have an x coordinate, but the y coordinate is going to be 0, okay? That means we can say y is 0. Okay, hopefully happy with that. Okay, well then y is 0 to find the missing x coordinate. Well, subbing y0 into this equation here, okay? So when y is 0, y is 4x minus 8. Well, instead, that be 0 equals to 4x minus 8. Then I can solve for x and then move 8 to the other side. So 4x is 8. That means x is divided by 4 each side. X is going to be 2. So therefore, P is going to be 2, 0. There we are. Cool. Okay, example 505b. Okay, let's have a look at some more detailed questions, shall we say. So this question then, quite an interesting one. Show that the points A, which is minus 2a, 5a, B, which is 0, 4a, and C, which is 6a, are collinear. What that means, it's a special word, you might see it thrown around at various points. It means all 3 points lie on the same straight line. So if I have a straight line here, say, as a general example, not necessarily the line that they lie on, but just drawing a line. Say A is going to be there, B's there, and C's there, say, for instance. They all lie on the same line. Okay, so how do we work with that then? Well, if they all lie on the straight line, well, can't we find the line that goes between A and B? And then if we find the line, which is mx plus c, okay, between A and B, that means the point C, I can substitute it into here, into this line we found out, and it should work, right? Which should then mean all 3 points are on the line. Anyway, so the first strategy then, let's find an equation between points A and B, okay, first of all. So, first of all, I notice between 2 points I can work out the gradient. Remember, a line, mx plus c, I need the gradient and I need the y-intercept c, okay? So the gradient between A and B, I'm going to call MAB, okay? Again, you might see this notation, M with a subscript, so I'm writing it in lower size, AB, which represents the gradient M between AB. Anyway, I'm going to work out the gradient between A and B, so again, that's going to be changing Y over changing X, as we discussed earlier. So again, changing Y, well, I'm going to take B as the point first. So first of all, the Y coordinate of B is 4A. Again, A is algebra, but don't worry, we do the exact same thing with letters as with normal numbers. So we have 4A, and then take away the other Y value of A, it's going to be take away 5A. Then the X value, the change in X, well, B I'm going to take first, so 0. Take away the other X value at A, which is minus 2A, so minus 2A. Then I can simplify this, so 4A take away 5A is minus A. Over 0 minus minus, that's going to be a plus, right? 0 plus 2A is going to be just 2A. Well, actually, that simplifies, doesn't it? Because minus A over 2A, the A's will cancel, so you're left with minus a half. So therefore, we've got a gradient. Okay, well then, that means we can start to complete our line, because then y is minus a half x plus c, okay? So now we need the y-intercept, okay? Now this is a good question, because most questions you won't be given the y-intercept you won't be given the y-intercept directly. Instead, what we can do in this situation is once we found the gradient, we can substitute a point in. Okay, let's say B. Okay, that seems more simple because there's a 0 in it. If I substitute B, so substitute 0 for A, into this equation of a line for y and x, because that's the x and the y coordinate, I can then get an expression for C, right? Anyway, substitute 0 for A in. That's what I'm going to do. So, but x is 0. So that would mean, well, x is 0, y before A. So that means 4A for y would be minus a half of 0 plus C. Now, if this is 0, this whole thing goes to 0. So simply left with 4A is equal to C. But there we are. That's our C value then. Our y-intercept is 4A. Therefore, we can say overall y is minus a half of x plus 4A. Okay? So that's our equation of the line. And that's the equation of the line through AB. Okay? So we call that line AB. Okay? Now, we need to show that all 3 points here lie on the straight line. What I've done here is shown that AB lies on this line. I then need to show the other point C also lies on this same line that I've worked out. Well, how am I going to do that? Well, let's just substitute the coordinate C in. Right? So if I substitute C in, and then this works, well, that means C has to lie on the line. Anyway, let's do that then. So sub 6, the coordinate 6A and A. There. Then that means y is going to be A. And so x is then going to be 6A, so minus a half of 6A plus 4A. Okay, but then if I simplify this, A is going to be minus a half times 6. Well, that's going to be minus 3A. Because 6 over 2 is 3, then minus 3A plus 4A. Okay, well then I get then A, if I simplify the right hand side, is 4A take away 3A. A is equal to A. Well, yes, that is true. So therefore the point must indeed lie on the same line. It lies on this line. So C, I don't want to use too much more space here, but so therefore C also lies on line AB. So so all points are collinear, okay? Because again, collinear means that all points given, so in this case A, B, and C, they all lie on the same straight line, okay? So there we are. Cool. Let's have a look at these questions then. I think these are the last two. Yep, cool. Let's finish off with these two. So question 11. The straight line L passes through 0, 6 and has gradient minus 2. It intersects with the other the line with equation 5x minus 8, y minus 15 is 0 at the point P. Find the coordinates of P. Now, this is basically two lines, right, intersecting each other like this. Say we have a line there, we have a line there. That intersection is going to be P, okay? Well, what that means is, if you remember when we did our work on simultaneous equations, if you can find the equation of both these lines, we can equate them together, which will give us that point of intersection P. So that's what we're going to do then. We're going to find the equation of both lines. So firstly, the straight line L, we're not told what the equation of the line L is, but we are told it passes through 0, 6 and has gradient minus 2. Now that is enough information to work out this equation in mx plus c form, okay, which will help us. Firstly then, the gradient's minus 2, okay, that's given to us, cool, so then we can say y is minus 2x plus c, then we just need to find c. Now, it turns out this is the y-intercept actually, because the y-intercept, again, remember, is on the y-axis when x is 0. Well, if x is 0, but then the y is 6, so therefore C is 6. Alternatively, if you didn't recognise that, you could just substitute 0, 6, that point, into the line to then get, well, if y would be 6, so then x would be at minus 2 lots of 0 plus c. Well, that all goes to 0, so then 6 is equal to simply c. Okay, if you didn't realise it was a y-intercept already, because that's when x is 0. Anyway, so c is 6, so therefore y is minus 2x plus 6. There we are, we've got our equation of a line. Cool, so that's the line of the first line L. Then it's intersected with this equation here, this other line, which is 5x minus 8y minus 15 is equal to 0. Okay, well these are effectively simultaneous equations, right? Because when these two equations are the two lines and they both intersect. So we need to equate them together. So let's equate the y value together. So that means that I'm going to substitute, because this is the first equation, right? It's already rearranged for y. So I can substitute that y into the y here, okay? So therefore, 5x plus minus 8, and then I'm going to substitute the y in from the other equation. So it's minus 2x plus 6 minus 15 equals 0. Then I could just expand it, right? So then 5x minus 8 times minus 2 is plus 16x. Then minus 8 times 6 is going to be 48. So minus 48. Minus 15 equals 0. Right, then this is just a simple equation in terms of x to solve. So that's 5x plus 16x is 21x. Then minus 48 minus 15 is minus 63 equals 0. Cool. Okay, well then I can then move it to the other side to get 21x is equal to 63. That means x is 63 over 21, which will turn out to be 3, I believe. Okay, so that's the x value. Okay, but then the y value, I can then substitute it back in to either equation here. But I'm going to substitute it into this one because it's already nicely rearranged. So then, therefore, y, remember, is minus 2x plus 6. That's going to equal minus 2 lots of 3 plus 6, because x is 3. And that will be minus 2 times 3 is minus 6, plus 6 will be 0. Okay? So therefore, x is 3, y is 0. Which means the point P, which is this coordinate, is when x is 3, y is 0. Okay? So that's our point of intersection. Cool. Then part 12, if I have enough room, I can make room. Okay, question 12 says, the straight line L1 with equation y is 3x minus 7 intersects the straight line L2 with equation ax plus 4y minus 17 is 0 at the point P, which is minus 3b. So it's a sort of similar situation, but the same situation as the idea of two lines intersecting at a point, but this time the information is slightly different. So we need to find the value of b here and then the value of a there. So okay, so part A, well, again, these two lines, so they're giving us the two lines quite nicely, the two equations. That's the first line, that's the second line, and they intersect at this point here. Okay, well, if they intersect at a point again, remember, it's like simultaneous equations, the two lines equal each other at this point, right? That means I can substitute this point into either equation, right? And it will work, okay? So then if P is equal to, which is minus 3B, first what's we define B? Well, I could substitute that point into either line. And actually I think it's best to pull it into this one, right? Because then if y is equal to, so I'm going to sub that, so I'm going to say sub P, the point, into y, the straight line. Y is 3x minus 7. So the first line that's given to me. And that will give me that, therefore y would be b, the y coordinate is b, and so the x, so then we have 3 lots of x, which is going to be 3 lots of minus 3 minus 7. Well, that's easy, that gives me b, right? So then I can just calculate that. That means b is going to be 3 lots of minus 3 is minus 9, minus 9 minus 7 would be minus 16. There we are, cool. Then part B that says to find the value of A. Well, now we found B, so that means P is now minus 3 minus 16. Because now we know what B is. Now we're going to do the same thing then, because A is in this equation of the line, this line here. So then I'm going to do the same thing. So this point would also satisfy this line here. So I'm going to substitute the point into this line equation there, okay? And that will allow me to find A, okay? So then I'm going to say sub P into the line AX plus 4y minus 17 equals 0. And there we are. So then if I substitute P in, well, P is minus 3 minus 16, that means x, so ax is going to be a lots of minus 3 plus 4y, so 4 lots of minus 16, which is the y value, minus 17 equals 0. Then I can just expand and simplify. So a lots of minus 3 is minus 3a, 4 lots of minus 16 would be minus 64. Cool. And then we have minus 17 equals 0. Okay, well then that means minus 3a. Then can simplify the numbers. So minus 64 minus 17 should get me minus 81. But then I can move the number to the other side. So minus 3a is equal to positive 81. Well, a is going to be a minus 81 over 3. If I'm divided by minus 3, that would get me minus 27 if I simplify. There we are. So there we are, that's our value of A then. Cool. So there we are, that's equation of a straight line, the intro to the chapter. And yeah, hopefully you are starting to get used to the mindset of we can use algebra to get equations, to solve equations, to get certain values out or find certain information. But yeah, so that's straight lines for now, mx plus c form, but I'll see you next time.